Good evening and welcome to a new week with the Electric Trucker. It's Sunday evening and at 10 p.m. trucks are allowed to drive again. I'm heading pretty far this time near Magdeburg, which is actually over 500 kilometers, or about 310 miles, from Mühldorf. What's special about this trip is that I'm driving with an empty trailer. I was a bit surprised when I got this assignment, but I can explain why it makes sense. In logistics, the usual setup is to have regular clients around the company's headquarters. These are your main customers with fixed contracts and good conditions, and you want to prioritize them. That's what we typically do. Then you also take deliveries from all over Germany or Europe, which often leaves your truck far from home. To get it back, you book a return load through platforms like Timo.com. These platforms are used by everyone, including international companies, so the rates are not amazing, but it's better than driving back empty. This way you at least cover some costs. The fuel or electricity gets used anyway, so picking up a load helps make the overall trip more cost-effective. But this time we're so busy that I'm heading to a regular customer near Magdeburg who has a shipment heading northwest toward Leer. The catch is, I need to pick up this load between 9 a.m. and 3 p.m. because it's time sensitive. If I squeezed in another trip towards Magdeburg, I wouldn't make it in time. That's why it actually makes sense to leave now and ensure I'm ready to pick up the load early. And financially, it still adds up. And driving empty with an electric truck isn't as big of a deal since operating costs are lower. Technically, I could have started driving early Monday morning, but then everything would have to go perfectly. By leaving now, I have the advantage of empty highways and empty charging stations along the way. But it goes against my internal clock, and I'd rather be sleeping right now. But I've got coffee, an energy drink, and no time pressure. Something that's definitely worth a lot as a truck driver. One thing I've never talked about is the quietness in the city. People are going to sleep, and I'm just rolling silently through the village. Decades from now, we'll wonder why we ever allowed so much noise in our towns and cities. Of course, there's still some noise from the trailer, but the acceleration, which would normally be super loud with a diesel engine, is way quieter. Everybody must like it. Who would seriously say, I'd prefer to have more noise at night? I've got 37% battery left, but there's a good charging station coming up. From a distance, it looked like a great place to charge, so let's check it out and see if it holds up. It's 2 a.m. on a Monday morning, and there's absolutely nothing going on here. The gas station is quiet, and most truckers are sleeping. I parked straight ahead with plenty of room for cars or even trucks to pass by. You could even drive around the back, but like I said, no one's around anyway. Driving at night is really awesome because you don't encounter many electric cars, and the Volvo parked here isn't even electric. There are some people sleeping in it after a long trip, and I won't bother them. They deserve the rest. I'll take a 45-minute break, then I've got another 3-hour drive to the next charging station before I'll get to my destination. There's plenty of buffer time, which makes this a very relaxed trip. I'm now in Bitterfeld, and I can already see lots of glowing charging stations. A Model Y driver recognized me, and we had a fun chat. At this location, there are superchargers, more superchargers further back, and Ionity stations. I parked up front and checked things out on foot first because you can't actually drive through back there. The area just ends, and there are signs saying only electric cars are allowed to park here. Those signs are set up perfectly to be knocked over by a truck. Technically, trucks aren't allowed in here, but given the time, I pulled over to the right where no cars are parked. Still, this location isn't suited for trailers. There are lots of truck parking spots nearby, so it's clear that you should unhitch the trailer. You can already tell, though, there are stones everywhere, so trucks aren't exactly welcome. I'll just reverse out when I'm done, but this is definitely not a place you'd want to visit during the day when it's crowded. The battery level is now at 52%, but I'm getting tired. My personal battery level is running low. Earlier, I've loaded some steel beams needed for a construction site along with a few pallets. Securing everything was a bit tedious, but the weight is only around 10 tons. I need to deliver everything tomorrow at 9 a.m. sharp. For now, I'll drive west for another hour until my driving time is up. Then I'll have covered 700 kilometers today, or about 435 miles. Driving through the night has been fun, but I was unprepared. Only Sunday afternoon I looked up my schedule and concluded that it was the best option to start driving Sunday night. If I'd known that earlier, I'd have taken a nap. So a bit of a planning error on my part, but everything worked out in the end. Now I'm looking forward to my rest break and my well-deserved sleep. It's been a perfect day. I've got 10 minutes of driving time left, which I'll use to reposition the truck, and I still have an hour of shift time. It's kind of crazy to start a 15-hour shift when most people are heading to bed. With 10 hours of driving, charging brakes and loading itself, you really can't do more than that. Now I can take some good rest until early tomorrow morning. I've been at this charging station before with the Scania. There is plenty of space both front and back, and it's actually nice because you can drive through forward and park directly. It's a regular car spot, but it's perfect for the truck. And that's all I've got for now. See you tomorrow. It's 5 a.m. and the first thing I did this morning was reposition the truck so it could charge up while preparing for the day. I've got a 9 a.m. delivery appointment and I've got plenty of time to spare. After that, I'll head to drop off the empty goods, which is another 330 kilometers away. I could charge in between, but I'm going to push it since the conditions are good. The battery is warm, it's fully charged, and it's not raining. The truck is ready to go, but it's complaining about some assistance systems being offline. We're at 100% battery, and I'm switching on the energy saving mode. This reduces the top speed to 80 kilometers or 50 miles per hour and limits acceleration power. Let's see if that makes a difference. In my opinion, speed has the biggest impact on energy consumption, just like with cars. And I don't think the energy saving mode lowers the climate control. In cars, the heat pump usually has a small effect on energy consumption. And at cold temperatures, it's around 10% at most. In the truck, the interior consumption is relatively small. Even if it were 5 times higher, it'd still only be 2%. So I don't think the energy saving mode will make the driver freeze. I'm almost at my destination now. It's a good reminder to always double check the route beforehand because the GPS was going to send me in a completely different direction. There's a big construction site right at the location, so I called my contact and they confirmed that I should drive as far as I can, then turn left. If you're curious and into technology, this job is an absolute dream. There's a substation here and it's actually explained what's going on. In the Borwin 5 project, TenneT is realizing an offshore grid connection with a capacity of 900 megawatts. The wind power generated at sea is directed as alternating current to the converter platform Borwin Epsilon, where it's converted into direct current. From there, it's transported with minimal losses over a 120-kilometer long sea cable and a 110-kilometer long land cable to the converter station Garrel Ost. There, the direct current is converted back into alternating current and fed into the high-voltage grid through the associated substation. Completion is planned for 2025, and from here, it goes straight to Nano Janssen into my truck. Ich find's mega geil. I've unloaded the trailer and can now pick up fresh goods. I'm heading south to load and then deliver to Wittmund, which is in the far north. It's going to be a shuttle service, meaning I'll drive the same route several times. Range-wise, today was perfect. I'll charge up now and take my lunch break, but I've still got 132 kilometers left, or 30% battery. That means I've managed 330 kilometers on a single charge. If you drive a bit more carefully, 350 kilometers is definitely doable, maybe even 400. Today, though, the consumption was higher due to a lot of rain. I switched on the eco mode, but it didn't have much of an impact. It actually switched off by itself. I thought once you activate it, it stays on, but it didn't. But my conclusion is that speed has the biggest impact on consumption. Whether you accelerate a bit faster or slower doesn't make much of a difference. It's all about how much slower you drive. And this isn't really related to the energy saving mode because I can just drive slower without it. Now I'll only charge enough to make it back to the depot since I can't unload today anymore. And charging is way cheaper there. I'm also going to test limiting the charging power and charging in a way that's gentler on the grid. I was just in Neuenkirchen-Werden and recharged the truck. I've been there so often that I didn't record a video. I charged it to just over 80% and now I've got enough range to get to the loading point and then back to the depot. I recalculated and I've driven 330 kilometers and used 79% of the battery. If you project that consumption, the range is over 400 kilometers or 250 miles, which is pretty impressive. The Volvo is quite efficient if you don't accelerate aggressively and drive around 80 kilometers per hour. And in the end, fuel consumption is the only thing that matters to logistics companies. They just want to know if all the deliveries were made on time and what the fuel consumption was. If a truck with a smaller battery is cheaper and still meets all the deadlines, it doesn't make sense to buy a larger battery. Plus, a smaller battery automatically encourages you to drive more efficiently. With cars that have unlimited range, you don't have the sense and no real incentive to drive efficiently. And the more I drive the Volvo, the more I realize that I could drive it just as well all over Germany. Even if I lose a few minutes at the charging stations, the job still gets done on time, and I get paid all the same. I'm battling through the rain now, and will load up some cement. It's going to weigh a lot more than I originally accounted for in my route planning, but I will figure it out. I've arrived at the depot and there's a change of plans for tomorrow. I was originally planning to be on the road all day, but we're getting an introduction for an electric forklift. I've always wanted to try driving a forklift that's attached to the trailer, where you can load and unload the goods yourself, but we've always used diesel ones which have really loud engines. Now we're getting an electric one to test out. I'll also be getting a forklift certification and then take a tour with it. Arriving with an electric truck and loading goods with an electric forklift, I will be so quiet, people won't even notice their goods are being picked up. Do you know that feeling when you have an appointment and your companion is impatiently waiting for you? That's what's happening here with Crimelix, who really wants to go for a walk, and I'll do that in just a moment. I've been tracking all the data from the charging sessions and trips, which allows me to compare the Iveco with the Volvo. On two similar trips, both were loaded with 10 tons. The Iveco had a consumption of 1.25 kilowatt hours per kilometer, or 2 kilowatt hours per mile. The Volvo, on the other hand, consumed just 1 kilowatt hour per kilometer, or 1.61 kilowatt hours per mile. That's a reduction in consumption of about 20%, and therefore cost savings of about 20%. That is not just a marginal difference. When a truck has 20% lower operating costs, the choice is clear. You stick with the more efficient one. I find it fascinating how economical the Volvo is, but that's because it naturally encourages efficient driving as you're always mindful of the range. That's an interesting aspect you don't really experience with the Iveco. Once my Iveco is back, I'll try to drive it as economically as possible to compare the results. Good morning. Today I'm at the company Terberg, a manufacturer of specialized vehicles. Here is a large workshop showcasing specialized vehicles like those used in container terminals or ports to quickly transport trailers or containers. These aren't meant for public roads and are very driver-focused, designed for a completely different use case than a standard truck. They feature powerful hydraulics that can lift the fifth wheel significantly higher. You just lift it up to pick up or drop off the trailer. This greatly speeds up the process of moving them around on the yard. And here you can see what forklifts usually look like. Forklifts that can slide into the back of the trailer. These are typically four-way forklifts, meaning all three wheels can rotate independently. The front wheels can even turn in such a way that the forklift can move completely sideways. This makes them incredibly flexible when it comes to unloading in tight spaces. These forklifts can be securely mounted to the rear of the trailer with the license plate attached to the back since it becomes the end of the truck. This means it also requires proper rear lighting. The whole system is hydraulically driven with a diesel engine powering a hydraulic pump that drives all the wheels. But the drivetrain has its limits, and these forklifts aren't built for high speeds. Now I'm in the back of the workshop with our new fully electric forklift. These forklifts can be very loud because their diesel engines are not well insulated and rattle quite a bit. That's where this one is different. It features a fully electric drive, but otherwise, the basic concept remains the same. It still has the same wheels and hydraulic systems driving its functions. However, the real innovation is hidden under this cover. Here you can see the technology. There's a large electric motor installed replacing the diesel engine. The electric motor drives the hydraulic pump, which in turn powers the other wheels. I was surprised because I would have thought they'd go straight to using hub motors. But since this is the first generation, they've kept as much of the original design as possible. This approach ensures compatibility with existing components, and workshops won't have to adjust to a completely new design. At the top is the electric motor powered by a lithium iron phosphate battery with a capacity of 17 kilowatt hours right below. Additionally, there's a 24 or 12 volt battery to support the electric motor. What's interesting about these types of vehicles isn't the range, but rather the operating hours, which depend heavily on usage, whether it's covering long distances or lifting heavy loads. The hydraulics are needed not only for driving, but also for lifting and lowering the forks, as well as for rotating the front wheels. Even if the motors were upgraded to hub motors, you'd still need hydraulics for the fork mechanism. There's a switch here to turn the system on and off, and you can check the battery status, currently showing 76%. At the top of the display, you can see the total operating hours, which is just 10 so far. You can also monitor temperatures for the battery and motor. One notable feature that stands out is the seat heating, which isn't standard. Even though the operator is somewhat sheltered, they're still exposed to the cold, so having a heated seat is a nice touch. In addition to the main controls, there are extra levers at the back for external operation. These allow you to adjust the forklift while it's attached to the trailer, such as raising or lowering it from outside. Let's talk about charging. This is the standard connector for the trailer's lighting system. This ensures that the lighting, such as brake lights and turn signals, work properly at the back of the trailer. Above that, are the more interesting connections. There are two ways to charge the forklift. One is via 24 volts, which is useful if the trailer has a suitable socket at the back, but the upper connector is a bit unusual. It's an inverted Type 1 connector. This is the plug that gets connected but is not meant for public charging. This connector allows the forklift to charge using three-phase or standard household power. There are two cables, one for single-phase charging and another with a Schuko plug for regular home outlets. The Type 1 connector is plugged in here, and now I'm going to connect the Schuko plug to the socket. As you can see on the interface, not much has changed. The only thing you can see is that it's charging, and the current battery level at 76%. There's no additional information displayed, so the charging power isn't shown either. It takes 4 minutes to charge 1%, which corresponds to a charging rate of 2.55 kilowatts. The question is whether this will really make a difference in everyday use. You'd start the route fully charged, and the question is whether it will last through the whole week. But it's really cool that we now have an electric truck with an electric forklift. That's future on top of future. We've rented it for 4 years, and we'll test whether we want to keep it. The real test will be how well it works in summer and winter. Then we can see how many we want to replace. You can still hear the hydraulic motor, so it's not completely silent, but it's absolutely nothing compared to normal diesel forklifts. Now let's take a look at how it's loaded. The special attachments at the back distinguish the trailer from regular ones. In this case, the lights can be folded to the side because you need space for the trailer. This way, space is created, and that's why these trailers are a bit more expensive and complex to accommodate the forklift. And now you drive the forks into the slots. You drive all the way in, then lift yourself up. You can see the trailer going down because it's quite a lot of weight. Now you pull out these beams from the outside or underneath, and then everything gets properly secured. And my Iveco, or many electric trucks in general, have the issue of too much weight on the rear axle, but with the forklift this is reduced. So it's actually a downside for a normal truck, but for an electric truck it's just perfect. Honestly, now I have a reason to drive around with it even if I don't need it. Now it's being secured with steel chains and the cable is plugged in to ensure the lighting works. Now you've seen how these truck-mounted forklifts work. I'll be sure to cover it in future videos as we have quite a few routes where we unload with them. It's definitely a nice change of pace. Now it's time to head back to Leer. Today is Friday, so it doesn't make sense to start a long-distance trip because I'd end up stuck somewhere over the weekend. Instead, I'm going to practice a bit with this forklift. I've already had a brief introduction and set up a small course to practice. To operate it, you turn it on, then use the left pedal to move forward or backward. The right pedal controls the motor's speed, allowing you to go faster or lift heavier loads. Even though it's turned on and showing 38% on the display, it won't move because it has a seat sensor. The pump only activates when you're sitting on it. As soon as you're in the seat, the system activates. This means the electric motor is running and driving the hydraulic pump. The motor has an idle power consumption, so even if it's stationary and you're sitting in it, it still uses power. And there are several switches here. One for the horn, indicators, a headlight, a parking brake, a rotating beacon, and a differential lock. There's also a switch to side driving mode, allowing you to turn the front wheels. Additionally, there's a hazard light button since it has rear lighting and a seat heater, which is obviously a must in winter. The left pedal is for moving forward and backward, and when you're driving in reverse, it also beeps. There are different levers here, one for raising and lowering the forks. You can also adjust the tilt of the forks, and if you want to place a pallet precisely, you can move the forks left and right without having to reposition the whole forklift. Plus, you can extend the forks outwards, and there's a lever for adjusting the width to accommodate special pallets or wider items. Let's test it out and pick up the top pallet. I need to drive carefully, and now I can adjust the forks to the right.
Und dann nimmt man sich hier die Palette,
Then I pick up the pallet,
hebt die an
lift it,
und dann geht's los.
and off I go. When driving, I can increase the speed with the gas pedal. You steer with your left hand and use the levers with your right hand. It's all about practice. So that's why I'm doing this now as preparation. If I keep this up all day, I might get it down eventually. And when I step out, it turns off automatically. There's a little chart showing the weight you can lift and how far the load can be from the forklift. If it's closer, you can lift up to 2.5 tons, but if the forks are extended out all the way and raised to the maximum, it's only 1.6 tons. If you exceed that, it'll tip over. Right now, I'm at 800 RPM, but I can increase it by pressing the gas pedal, and it'll reach about 2000 RPM. There's also a button with a little rabbit icon. If I press that, it speeds up even more.
Overboost.
You might think that since it has a Type 1 connector, all you'd need is a Type 1 to Type 2 cable, and you could charge it at a public charging station. But that's not the case, because the charging station requires a certain type of communication. With Type 2 charging, it's resistors that are switched, and through the resistance, the station can detect whether it's going to charge or not. It's really simple, but there's no communication inside this cable, so it won't work. What you can get is an adapter from Type 2 to Shuko. This adapter comes with a switch that you can press to communicate with the station to tell it whether you want to charge or not, and it also unlocks the plug so you can remove it. So I could charge in an emergency, and if I'm at a customer's site with a public charging station, why not? And I'd rather have the adapter with me, even if I will never need it, than need it but not have it. I let it charge for 123 minutes, and it went from 21% to 53%. This means it will take 384 minutes, or about 6 hours, to fully charge. So it will definitely be fully charged overnight. Now the interesting question is, after how many operating hours the battery will be at 0%, and I'll try to find that out once I can take it with me. To wrap up the forklift topic, I'll show you the different trailer variants here. The old version has the rear lights that fold away, which is risky because they might be forgotten. This is problematic for impact protection, and it also means the lighting is absent. So it's suboptimal. When they are folded out, there's also the risk of hitting them with the forklift. The newest version mounts the rear lights at the top, so they stay there and aren't in the way. I think this is the most common solution nowadays. You still have a bumper at the bottom to prevent any accidents, but it needs to be manually unfolded. Another increasingly common solution is the lights that fold to the side, which have the advantage of being visible. They aren't as easily seen, and the indicators might point the wrong way, but it's a good middle ground ensuring the lights are still visible, so nothing can go wrong. That's it for this week. Wishing you a great day and see you next time.